Hi, hello friends, welcome back to Max Lecture Series. So, in this session, we are going to learn how to solve directional derivative type of question. In your examination, if you are requested to identify the directional derivative of a function, how to do that? It's very simple. In this series, we are learning all the concept directly through problems. So, the one and only thing what you have to do is don't take any notes. Just watch the complete playlist. If you are observing directional derivative, watch the complete videos of the directional derivatives. After that, directly take the question, try to solve, you will be getting the answer. You don't need to take any notes at all. Let us learn how to solve directional derivative type of questions. In the question, if you are requested to calculate the directional derivative, then the step number 1, what you have to do is always write down the directional derivative formula. What is the directional derivative formula, sir? I am simply writing directional derivative d dot d. It indicates directional derivative. It will be equal to del dot f. So let me write 1 minute. That is inverse of del. It will be represented like this. So del f in product. We have to keep vector A upon mod A. This is the first step that you have to write. Sir, what is this? The thing is, nothing is there. This is represents gradient of f. This del, actual name for this is, it is simply called gradient. How to write this gradient? I will tell you one by one. First understand. This is the formula for directional derivative. First step, you have to find out the gradient of a function. F indicates the function that will be given to you. This is the function f. For this, we have to identify the gradient. After that, what this a vector by mod a vector indicates? Always, mod means we have to identify the magnitude of the function. That is the meaning of mod. After that, a indicates the direction of the vector. If you observe in this question, direction of the vector is defined in terms of a. That's why I have taken a. In some people, in some cases in your examination, they will be using p, or sometimes they will be using some other variable. It doesn't matter in which variable which variable they are using in the examination. Don't be focused on it. Just observe the word where they are giving this direction of the vector. Direction of the vector indicates a. So this will be defined as direction of the vector. I hope you all understood the meaning of all given terms in the formula. Once you understand this, see there. Let me teach you what is this gradient. Write down the formula for gradient. Gradient can be expanded as, this can be further written as, how can I write this? Dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector. It is very easy. If you are observing this very first time, don't worry. After watching 2 to 3 problems, you will be understanding that how much easy it is. So this is the representation of gradient. Now, if I am multiplying a constant with the gradient, then how can we write this? See, suppose if I am multiplying a constant on both sides, on LHS and RHS, if I am multiplying, not a constant, a function, then what will happen? In that case, you have to open up the bracket in the RHS side, that is right hand side. Each and every function, every term will going to be multiplied by f. So this can be further written as dou by dou x into I vector plus dou f by dou y into j vector plus dou f upon dou z into k vector. That's all. This is how we are representing the gradient of a function. Okay, sir. Now, function is given thus. See there. In your question, function f is defined as, take the question, 2x square plus 3y square plus z square. Let me write one more time. 2 times of x power 2 plus 2 times of y power 2 plus z power 2. That is the given function. I hope I am correct. Let me cross check one more time. 2x square, see there, that is 3. Sometimes these mistakes will happen. This is 3. 3 times of y square plus z square. Now what I have to do, sir? Let me continue further. If you observe the first term in this gradient of f, that is dou f by dou x. It means we have to differentiate this function with respect to x. So when we are differentiating this function with respect to x, all other variable will become constant. So differentiation of this whole function with respect to x. In the first case we have x square, differentiation of x square will become 2x, already 2 is there, so totally it will become 4x. Rest of people will going to be 0. Why they are going to be 0? Because when the moment you are doing the differentiation with respect to x, all other variables are going to be constant. If you differentiate constant with respect to x, that will become 0. So the overall answer for the first term is 4x. Let us take the second one. It means I am going to differentiate the same function with respect to y. If we repeat the same function with respect to y, what will happen? X and z are going to be treated as constant. So those values will become 0. So differentiation of y square will become 2 times of y. Already 3 is there, it will become 6 times of y. Z will going to be 0. So the resultant answer will be 6 times of y. Similarly, if we are trying to find out the same function with respect to z, when we are doing the differentiation with respect to z, x and y are going to be treated as a constant. So first two terms will become 0, only third term will exist, that will be 2 times of z. Once you find all this, substitute here, dou f by dou x equal to 4 times of x into I vector plus dou f by dou y equal to 6 times of y into j vector plus dou f by dou z equal to 2 times of z into k vector. That is how we are identifying the value of gradient of f. Once you identify this, then we can substitute this value into the formula. See there, value of a vector is already given. Value of a vector is I vector minus 2 times of k vector. How will you identify the magnitude for this function? Let me tell you, a vector is defined as I vector minus 2 times of k vector. Am I right? So this is defined as I vector minus 2 times of k vector. Okay sir, how will you identify the magnitude for this function? This magnitude can be written as just magnitude equal to square root of coefficient of I is 1, so 1 square plus coefficient of j. Is j is present in your a vector? No, if it is not there, then 0 square. Coefficient of k is minus 2, so minus 2 whole square. That is how you are identifying the magnitude. From this I can say minus 2 whole square will give you plus 4. Plus 4 plus 1 square. 1 square will become once again 1 only. So 1 plus 4 will be 5. We can write it will be square root of 5. That's all. Now let us substitute all the values into the final answer. Gradient of f dot a vector by mod a vector. This will be equal to gradient of f can be written as 4x into I vector plus 6 times of y into j vector plus 2 times of z into k vector. Okay sir. Now one more thing, we can directly substitute the values for x, y, z. See, it is already given. This function is defined at a point 2, 1, 3. So value of x equal to 2, value of y equal to 1, value of z equal to 3. Let us substitute, that is 2, 1, 3. First we will substitute. So here we are going to substitute 2, here we are going to substitute 1, here we are going to substitute 3. So that is what they given. So instead of writing this, directly we will write the final step. So always the value of x, y, z will be given in the examination. Directly substitute those values first. If I will substitute the values, 4 times of 2 will become 8 times of I vector plus 6 into 1 will become 6 times of j vector plus 6 times of k vector. That is the value of gradient of f into, what is the value of a vector here? The value of a vector is going to be I vector minus 2k vector. We already know that this will be I vector minus 2 times of k vector. In the denominator, magnitude of a we found, that is square root of 5. Now tell me what will happen in the final step. Sir, here we have to multiply this first vector with the second vector. How will you do the multiplication here? Always remember, the product of, in the vector multiplication, the product of I vector dot I vector will be equal to 1. Similarly, the product of j vector dot j vector will be equal to 1. Similarly, the product of k vector dot k vector will be equal to 1. All other type of products will be 0. All other type means what? I vector dot j vector, I vector dot k vector, j vector dot k vector, k vector dot j vector, whatever the other combination, all other combinations are going to be 0. Only I with I will be giving you 1, j with the j will be giving you 1, k with the k will be giving you 1. This is called a dot product. Remember this, I am putting dot here. So this is called a dot product. So this value will be equal to 1. It means when the moment you are multiplying the first vector with the second vector, I vector dot I vector will be giving you 1, whereas its coefficients, see here the coefficient is 8, here the coefficient is 1, so 8 into 1 will become 8. So you can't multiply this I with the other variables because I into k will become 0. So I am not going to consider that. Similarly, j dot j, first us, in the first case we have j, 6 times of j, whereas in the second case j is not there. It means it will be 0 times of j vector. Now tell me what is the product of 6 into 0, it will become 0 only, plus. Third one, here we are having 6, here we are having minus 2, that is product of, that is coefficient of k vector. 6 into minus 2 will become minus 12. So let me replace it by minus 12. Whereas in the denominator we will be having square root of 5. Now tell me what will happen. 8 minus 12 will become minus 4. So minus 4 by square root of 5 is the correct answer for the given function. So the directional derivative of this given function is minus 4 by square root of 5. So this is the one and only standard formula for magnitude, sorry, for directional derivative. Just mark it. So in the upcoming lecture, I will be bringing more question, but it is your responsibility to bring the answer for the function. This is all for this lecture. Remaining things we will see in the next class. Thank you all.